I decided to go ahead and make part 4 of the video so you guys could see the wrap up of how we assess the fit of the least squares regression line. So let's begin. There are 3 techniques that we want to use in order to determine whether or not the least squares regression line that we compute is the best fit for our data. And the first one that we look at is the correlation coefficient, which we have called R. And the R value does 2 things for us. First, it gives us a measure of the strength and direction of the linear relationship. So we spoke about this before. If that number is positive, we know our association is positive. If that number is negative, we know the association is negative. And we also should know that the closer this value is to 1 or negative 1, the stronger the linear relationship will be. The next measure we want to consider is the coefficient of determination, which is R squared. And this does some things for us as well. It gives us a measure of how much of the total variability in the response variable can be explained by its linear relationship with the explanatory variable. So think back to the squares activity that we did in class. We know that we got a reduction in the amount of variation when we predicted from the least squares line as opposed to predicting from just the y-bar mean line. And so this measure, R squared, gives us an indication of how much improvement in prediction we have. And so the closer that value is to 1, the better the model or equation or line is for making predictions. And the last technique we want to use is to look at the residual plot and determine what we see. So the residual plot just shows the overall variation of the observed values from the least squares regression line. Remember that in general, we calculate the residuals by taking observed minus predicted. If you don't remember that, you may want to go back to video 3. When we see the residual plot, or when we're looking at the residual plot, there are 3 things we want to look for. First, we want to look for random scatter. It should look like paint splatter on the wall. There should be no significant pattern to the residual dots. Then we want to look for a balance of positive and negative residuals. There should be about the same number of residuals above the line as there are below the line. And lastly, we want to make sure that we see consistent spread across the X values. There should be no fanning. So in other words, there should be no increasing spread as I move across the X values from low to high. There should also be no decreasing spread as I move across the X values from low to high. Whenever we see this type of fanning or we see any type of curved patterns, not only will our regression line not work, no regression line will be good for making predictions for the data that we're given. In that case, we have to look at some nonlinear regressions, which we'll study closer toward the end of the course. Let's go back to the airlines example. You may want to grab those papers that you may have printed out from the previous video so that you have the data and the scatter plot right there with you. You will see a picture of this on the next slide, but it might help to have it in front of you now. The correlation coefficient for that relationship was 0.48, and keep in mind this tells us about the strength and direction of the linear relationship between these 2 variables. So I've just given us an interpretation here. The linear relationship between percentage of planes outsourced for maintenance and the percent of delays blamed on these airlines is positive and moderate. I've highlighted the word moderate here. Ideally, we'd have a really strong relationship. Next, we have the coefficient of determination. If we square R, we literally get R squared, and that number is 0.23. And so this tells us that 23% of the variation in delay percent blamed on airlines, the Y variable, can be explained by the linear relationship with the percentage of planes outsourced for major maintenance, the X variable. So those are just 2 scenarios or 2 measurements that we want to look at in terms of helping us determine whether or not this regression line is a good fit. And then the last thing we'll look at is the residual plot. What we see here is the original scatter plot and below the residual plot. You should recognize this as output from Fathom, and I'll give you directions on how to do this in your calculator. As a matter of fact, they're already on the blog, and so you should take a look at the blog to download those instructions. Keep in mind what we want to look for in the residual plot. Ideally, I want random scatter. I want something that does not look like a pattern. And so you may question, well, what is random? Something that looks curved, something that looks like any type of pattern other than paint splatter. Now, while we might consider this to be random, there's some other things we want to look at as well. We want to look at the balance of positive and negative residuals. And so literally we can just count. We have about 5 residuals below the line, and we have about 7 above the line and 2 that are really close to the line. And so is that a balance? I would say that it looks like we have more positive residuals than we do negative residuals. The last thing we want to be concerned about is fanning. What is happening to the spread of my residuals as my X values get larger? So in the beginning, as my X values are smaller, notice my residuals are really close to 0. However, as the X values start to grow or get larger, my residuals are moving farther away from the line and then coming back close to the regression line again. That is a cause for concern. We do not have consistent spread. And so based on those 3 measurements, R being 0.48, we only have a moderately linear relationship. R squared being 0.23, only 23% of the variation in delay percentage blamed on the airlines has anything to do with the linear relationship with what percent of their planes they outsource. And the fact that this residual plot shows inconsistent spread across the outsourced percentage, we should be concerned about using this line to make predictions. We could be wrong very often. As a matter of fact, R squared tells us we could be wrong about 77% of the time, which is not good. Okay, to summarize, keep in mind that no single measure is sufficient to determine whether or not the least squares regression line is a good fit. We must consider all 3 of these measurements. We must consider the correlation coefficient, the coefficient of determination, as well as any patterns or inconsistent spread that we see in the residual plot. So you should use all of the techniques that we've discussed in this video in order to make a sound statistical decision regarding the fit of the least squares regression line. Feel free to make comments below the video or below the blog entry, or send me an email if you have any questions regarding any of this. Keep in mind that your test is on Wednesday, so I hope that you're having a good 4-day weekend, but also spending some time trying to make sense of these concepts. I will see you on Tuesday. Take care.